for this side, which called what? Windward roof. This one, your pressure will be QH GCB minus QH GCBR. Remember, this value is a constant value, plus or minus 0.18. QH G 0.85 wind gusset. CB from your table. So I can figure out what's this value, what's this value, what's this value. But for this one, if you have different value of QZ, you have different value here. Remember, for your wind load, for this member, it will be in X direction. So you can choose capital X. For this one, you can choose capital X. But for this one and this one, we are going to use small y. Small axis means local axis. Any inclined member, your local axis, x or small x, in the same direction of your member. Small y perpendicular to your member. So however your member, your small y is perpendicular to your member. But for capital X or capital Y, capital X is a horizontal direction, capital Y is a vertical direction. Also, you can, if you want, for this one, I can use also Y. Because your vertical member has local axis X and the local axis Y. So I can enter this value in negative, small y, but I don't need to use this local axis for any inclined, vertical or horizontal member. I use local axis most of the time for any inclined member, because inclined member with this force, I cannot figure out this value is a horizontal value or vertical value. So I will use the local axis for these members only.
So then, for the capital X, you just put it in the same direction that the wind's blowing, right?
Yes,
It's gonna
yes.
be positive?
Yeah, yeah. Because your positive direction X like this.
That time.
Yeah.
Does it matter if the suction loads are significantly bigger than the wind load?
Say it again?
Does it matter if the suction loads?
No, no, I don't care.
No.
But most of the time, this value will be bigger.
And then for the test, if our angle is bigger than 10, we're just gonna assume those?
I'm sorry?
We only have values for 10 degrees for
On the little table.
on that bottom table there.
Okay, yeah. For 10 degree only, if you have greater than 10 degree, you have different value. Yeah, I will make it 10 degree. Because we have many tables but not available in our notes.
How do you get the average H?
Average edge, if your frame looks like this height 15 feet, this height 5 feet, that means your average height equal 15 feet, which is the height of this column, plus average height for this triangle, which is 5 divided 2. So your average height equal 12.5 feet.
17.
I'm sorry, 17.5. Once you get your wind pressure for this one, this side, and this side, and this side, and this side, go ahead and multiply this value by S. Because your wind pressure is a area pressure, is area load. Bound per unit area. I would like to convert it to line distributed load. So multiply this value, which is P on each side of your frame by S. You can get your wind load as distributed, line distributed load. Maybe one more time, we can have different value or one value or two value or three value based on what is the height of your column. Not the height of your, not the average height of your frame. Height of your column. If this height 15 feet or less, we have only one value. More than 15, we have different value, maybe two value, three value, whatever. Once you get your dead live and wind, go ahead and build your model on RISA, put your load and combinations and solve. Once you solve the model, finally you have three diagrams. You need to print this diagram. Also, you need to print this shape showing your load. You need to print this shape for wind load and this shape for dead load. So each case of load, you need to take picture and also the final results. The best scenario to take your picture on a Word file, then your Word file you can print it in one time or send it by email. Okay? Do you know how can I get, you can capture the picture from anything? Maybe you can get something called snipping tool, open it, new, and zoom or select what you want, copy, and open a Word file. And then paste. One more time.
Yeah, that's you know what I'm looking.
From search, snipping. Open it. If you would like to get a new picture, new, and then you can select what you want, like this. I got them. You can do some change. You can do lines, or you can highlight something, what you want. You can erase also, if you want. You can change color, black, red. You can do what you want. And then copy, open your Word, paste. You got what you want. Okay? So I prefer to get your results in a Word file better than direct print from RISA, because we have a demo version.
Dr. Hunter, you don't have to, I will need to draw those out like by hand or anything, do we?
By hand?
Yeah, like right there, whatever you did on the board, like do those.
Yeah, but I would like to see what you did on RISA.
I was saying, do you want us to do it by hand too, or just do it on RISA?
No, on RISA.
Okay.
Yeah, get your value in calculations and shapes on RISA. Once you get your results, what is the normal force value, which is compression, which will be P ultimate. This value, maximum value here, will be P ultimate from normal force diagram. From bending moment diagram, your maximum moment will be M ultimate. So go ahead, we have P ultimate, we have M ultimate, go ahead and select a cross section, white shape, and do your calculation to say, hey, my selected cross section is safe or not safe, but let me know. If your cross section is safe, say it's safe and economic. It's safe or more safe, not economic. or unsafe, I need to increase the cross section. But let me know, just only one trial, but let me know what do you think. Safe or more safe or unsafe?
Oh, Dr. Amen, I remember what question I had for our, you know how we use F critical and we have to say KL over R? What is our K situation for the frame? Is that fixed pin?
Good question. It's not a direct, it's not clear what is the end condition of your column. So we can assume it fixed. I cannot say, as you said here, as you define your support, if you define it hinge, so it's hinge. If you define it fixed, so it's fixed. What about the other condition? It's not clear, it's not hinge and not fixed. Something in between, but we will assume it fixed. For some reason, we have moment here. So I cannot assume it hinge. Also, I cannot assume it completely fixed. Something in between, but to make our calculation more simple, assume it fixed. So the end condition, assume it fixed. But for the second condition, the second end, as you defined your frame, and as given, if your frame is fixed, define it fixed. If your frame is hinged, it will be hinged. In this case, we have some chart, some line like this. Can tell you what is the exact value of K based on what is the stiffness of your column, what is the stiffness of your beam. Because if your beam, this one is considered the beam, this one is considered the column. If your beam is more strong, more stiff, very, very strong than your column, that means your beam making fixed to your column. In the opposite side, if your column is very strong than your beam, that means your beam just support your column so it can be thin. So based on what is the stiffness, I can figure out what is the value in between. Anyway, so it's fixed, okay? Your design is nothing. Your design is a combination between design of beam and the design of column. Which one? Yeah. So which condition I will use, this one or this one? So go ahead and get this relationship or this value P ultimate from Riza divided by phi Pn. Do you remember how can I get this value? Design of compression member. Phi Pn equal phi F critical area gross of your cross section. To get your F critical, go ahead and open your table for design of column. Design of column. You have a table called design of column. Open it, and based on what is the value of KL over R, you can get your F critical from this table. K based on what is the condition of your column. So if your column is fixed, your K equal 0.5. If your column is hinged, fixed, your K will be 0.7. What is the L of your column? What is the R? We have two R, Rx and Ry. I will use the smallest value. So based on this one, I can get F critical, area gross from table, phi, what's the value of phi? 0.65 or 0.75. Anyway, go ahead and get your value and get your design. Compressive strength. What is this value will be? Greater than or equal 0.2, I will use this equation. Smaller than, I will use this equation. Actually, we don't have my, so this term will be cancelled. This term will be cancelled. The only moment we have is M ultimate X. Your M ultimate from Riza is M ultimate X. So then go ahead and get your value here. Your value must be smaller than or equal 1. So if your value 0.9, you will say, hey, safe and economic. 0.3, safe but not economic. 1.1 or 1.5, say unsafe, we need to increase our cross section. Any question?
We are using the same cross section for the whole.
Based on what your value, if you are we are talking about column, but if you are talking about other parts of your frame, if you can look, your normal force here 29.3, that's right. Your normal force here 28 or something like this. It's okay, very close. Your P ultimate here and P ultimate here, very close to each other. Your moment, your maximum moment here, 41.88 M ultimate. Your moment here is 88. So this member has internal forces P ultimate and M ultimate very close to this member with B ultimate and M ultimate. That makes sense. So your cross section here will be the same like here. Just for the internal forces are the same. That's all for this PDF file. Nothing else. For this one, the most important one here, what is the design strength of one bolt? Page number 9 for this file, for this module. To be clear with you, I will give you something like this.